In our next short unit, we're going to continue learning about statistics. In the last unit, the data that we looked at was in a single list. But in this unit, we're going to look at bivariate data, which just means that we're looking at two lists of data at the same time. This data is often recorded in a frequency table. And the frequency table just tells us how many times a certain response occurs. The data usually comes from giving a survey, and it's called categorical data. As you can see in the two-way frequency table given here, there was a survey given to high school and middle school students about their favorite soft drink. 18 high school students responded that Coke was their favorite soda, whereas 6 middle school students responded that Sprite was their favorite soda. This data in the table shows us the joint frequency because both high school and middle school students were given the same survey with the same types of responses. If we add a row and a column to total up the rows and column of our joint frequency, then we have a marginal frequency. The marginal frequency just gives us a total of each row and column. Basically, we're putting the totals of our rows and columns in the margins of the table that we have, and that's why it's called marginal frequency. So if I add the first column, 18 plus 12 is 30. That means that we had 30 people respond that Coke was their favorite type of soda. 12 plus 10 is 22. 4 plus 6 is 10. 13 plus 28 is 41. So 41 people responded that Mountain Dew was their favorite soda. Now we can also total the rows. So 18 plus 12 plus 4 plus 3 is 47. That means that 47 high school students responded to the survey. If we add the second row, 12 plus 10 plus 6 plus 28 tells us that 56 of the students who responded were middle school students. In the last cell on the right, I can add the last column and I get 103. I can also add the last row, 30 plus 22 plus 10 plus 41. I should also get 103. 103 represents the total number of responses to our survey. In our next example, the survey question is, which Wednesday after-school activity are you involved in? Male and female students were surveyed, and the answers were basketball, math club, band, or they're not involved in any activity on Wednesday. You can see that this is a marginal frequency table because we have a row for the totals and we have a column for the totals. Some of our numbers are provided, but some of them are missing, so we need to use the provided numbers to fill in the numbers that are missing. There are many starting places. You might start with those that are not involved. There are 50 males not involved and 30 females not involved for a total of 80 students who are not involved after school on Wednesday. Sometimes you have to work backwards. There are 22 students involved in band. 14 of those are female. So if I subtract 22 minus 14, that means that there are 8 males involved in band after school on Wednesday. Pause the video right now and use some strategies to fill in the other missing numbers. Check your answer. Now we want to know how many students are surveyed, and we know we can look at this last cell over here, which is the total number of people and the total number of activities. So 180 students were surveyed. How many students are in math club? We can look at the math club column right here, and the total male and female students involved in math club is 36. Let's use the information from our two-way frequency table to build a relative frequency table. A relative frequency table just means that we're comparing the responses in our two-way table to all the responses that we got. When we compare in each category, we can use a fraction or we can use a decimal. We need the fraction to find the decimal, so let's start with that. We know that there are 30 male basketball who responded to the survey. And so if we compare that 30 to the total of 180, then that gives us a fraction. If we compare the female basketball, there were 12 compared to the total of 180, and we get that fraction. Now if we add those two fractions, we're going to get 42 over 180. So we're using the fraction bar to compare those two numbers. Let's fill in the table with those fractions for the other activities. When we get to the total column on the right, we should also have our total, which is 98, compared to the total for the whole survey, which is 180. And for females, 82 is our total over 180. So again, we're just comparing each of the cell numbers from our two-way frequency table to the total number of responses, which in our case is 180. Now if we add our last row and we add our last column, we should get a total of 1, and you can test that in your calculator. Sometimes the fractions are very useful to us, but a lot of times the decimals are going to be more useful, and in this case our questions ask what percent of students surveyed are male? What percent of students surveyed are females in basketball? So if we're talking about percents, then we want decimals. I can go to my calculator and I can clear that screen just to clean it up. And then my first fraction is 30 divided by 180. And then that will give me the decimal. Now there are two things you can do here. You can round to a certain number, or you can truncate, which means you just want to choose like the first 3 decimal places. And that's what I want to do. I don't want to round any of the answers. I just want to look at 3 decimal places and use that as my answer. So for this fraction, converted to a decimal, I'm going to use 0.166. So even though it was 1666666, I'm going to call that 166. So I'm truncating all of those extra decimal places. And the reason for that is that there's going to be a lot of rounding, which means there's going to be a lot of rounding errors. And so you just pick one way and stick with it. You'll see what I mean in just a minute. Go back to my calculator. I'm going to do 12 divided by 180, and that gives me 0.066. Typing your fractions into the calculator to get the decimal approximations. Notice that none of your decimals, none of your fractions are going to be bigger than 1, because 1 is 100%. It's 180 respondents over 180 respondents. So now we can answer the question from our relative frequency table, what percent of students surveyed are male? So if we look at male and go all the way across to the total, we see 0.544. If we change that to a percent, then we're multiplying that by 100, which moves our decimal 2 places to the right, and we have 54.4% of the people who responded were male. The next question, what percent of students surveyed are females in basketball? So this time we have 2 things that we're looking for. We want them to be female and participating in basketball. So that would be in this cell right here. If we change 0.066 to a percent, that's going to be 6.6%. Again, I multiplied by 100 to change that to a percent, which moves the decimal 2 places to the right. Turn the page over, and in the next example, let's add another word to this frequency table. This time we have a conditional relative frequency table. So it's still going to be relative. We're going to be dividing. We're going to be comparing to the total. But this time, one of the conditions is known. A flight attendant looked over a list of recent passengers. The list contained passengers' frequent flyer status as well as the number of bags checked. And below we have this frequency table. So we have bronze status and silver status, and then the number of checked bags down the left side. So 7 passengers with bronze status did not check any bags. 3 passengers with silver status checked 1 bag. And we want to analyze this data. First, let's start by making it a marginal frequency table by adding our totals columns. So here is my marginal frequency. Make sure you check your numbers. Now let's build a conditional relative frequency table given a passenger's status. So rather than compare the individual counts to the total number of passengers, which is 26, we're going to compare the individual status numbers to the total status. So for bronze status, 0 checked bags, we're going to put 7 over 12 because 12 is the total number of passengers in bronze status. And then we change that to a decimal. So compare 1 checked bag, bronze status would be 2 to the total in bronze status, which is 12. So the thing that's not changing, the total that we're using, is the passenger status, because that's the condition that we were given. Now when we total these, we should get 1 in our total column. If we add up the decimals, it may be something like 0.999, and that's just a rounding error. Let's do the same for the silver status. So for 0 checked bags, we have 2 compared to the total for the silver status, which is 14. 1 checked bag is 3 compared to the total for that status, which is 14. And then 2 checked bags is 9 compared to the total of 14. If we add those fractions, we get 14 over 14, which simplifies to 1. Now we just want to use the calculator to give us the decimal approximations for that. Now we can answer the questions below. If a passenger has a bronze status, how likely are they to have 2 checked bags? So we're looking under the bronze status and 2 checked bags, and that would put us right here at a 25% chance. What percent of passengers with silver status are likely to have 1 checked bag? So again, we're going to look in the silver column, and we want to go to 1 checked bag, and where those intersect right there is at 0.214, and as a percent, that's going to be 21.4%. Now let's use the same data, but this time we're going to have a different given. This time we're given a passenger's number of bags, and we want to find the frequency status. So notice my totals are not going to be underneath the status columns. They're going to be over to the right of the bags rows. And I'm going to be comparing to the total number of bags. So I'll use bronze status 0 checked bags over the total number for 0 checked bags, which is 9. So 7 over 9. And in the next, for silver, I'll do 2 over 9. So I'm using the total that's at the end of the row because that's my given, the number of bags, which occurs in the rows. So for 1 bag, the same thing. I'll take the 2 compared to 5, which is the total. I'll take the 3 compared to 5. And then in the third row, 3 compared to 12, and 9 compared to 12. Use your calculator to change those fractions to decimals, and you notice if you add the fractions across the row, 7/9 plus 2/9 is 9/9, which is 1. So these rows should all add up to be 1. If you're adding the decimals, then there might be a little rounding error, but it'll be 0.999 or 0.998 or something very close to 1. Now we can answer the questions. If a passenger has 2 checked bags, how likely are they to have a bronze status? So we want to go to 2 bags in bronze status, which is 25%. So even though the wording is different, we're getting the same answer that we did over there. So I wonder if that's a coincidence or if that's always. Let's look at the next one. If a passenger has 1 checked bag, what percent are likely to have silver status? So for 1 bag silver, we're talking about 60%. And so here's where we look at our data and is there anything that we can learn from this? Does one thing cause the other? I would probably say yes, that there's an association, that the silver status has the most bags. If you have the bronze status, then you're more likely to have fewer bags. Make sure that you think through your practice and ask any questions if you have.